Hi students, good evening to all of you, and today's session is going to be on your Kinematics 2D. We are going to specifically focus on the projectile motion questions, and yes, there will be some question related to your relative velocity also, okay? And I have taken one question for your circular motion, fine. So now students, the most important thing for today's session that you have been attending, first of all, let me know how many of you have actually enjoyed yesterday's session. And yes, that's the reason that you have come back here for the lecture in English and also for the sprint session of your Kinematics 2D. Alright, I hope all of you are as excited as I am to teach on this particular platform, isn't it? So guys, without any further delay, because we have already been 5 to 10 minutes already gone by, so we will right away start our today's session. Okay, now students, let me tell you, in our today's session, that is of Kinematics 2D, I have taken or hand picked some of the really important questions. All right, these kind of questions are like the examiner's favorite, okay, when it comes to your JEE mains examination. Getting it? Now, there generally your projectile motion question involves using lot of formulas and then going and finally getting the answer. Again, as I tell you, time is of essence for these examinations, so I am going to give you some of the real good shortcut tricks in order to solve these questions, so that even the questions which would take a 10 to 15 minutes time to be solved, I can do it within a span of 2 minutes maximum, and that question will be finally solved. Okay, so guys, put on your seatbelt and let's get started with our today's journey of Kinematics 2D. Fine enough? So what we have next coming up, that's an introduction of me. Those who are watching me live for the first time on the Unacademy channel, English JEE channel, my name is Sumit Kundu and I am a BTech graduate from IIT Bombay. My All India rank was 2125, and it's been more than 10 years that I have been teaching, mentoring, motivating, encouraging students to have a beautiful career in the field of engineering. All right. Now students, something very important also, that the tinyurl.com/JEE mobile, this is the last final minutes of your preparation. So go ahead and check it out. You will have the archives of all the lectures that has taken place in the past 1 and 2 years. All right. And do not forget, go for the subscription, and when you're going for the subscription, do not forget to put on this particular code, that is your SMLIVE, and get right away 10% discount. This is for your 12 months subscription. Definitely we have different other packets as well, so once you have actually installed the app and when you're going ahead to do it, you will find all of it. Okay, so not to worry about it. And now I've kept the pitch a little short, so that now we can go ahead and start off with our today's discussion. The question is right in front of you, isn't it? Simple question hai? This is not a very difficult question. Okay, now it's definitely been handpicked, so only the important concepts in projectile motion we are going to highlight for you guys. So in this question, what do we see? I'll read out the question to you. And finally we'll see that, how we can go ahead and solve it. Okay, standard method we are going to use. There is no shortcut for this particular question. We are going to use a standard method. Initial speed of a bullet fired from a rifle is basically, so what color do we use? Let me use a blue color. So initial velocity is 630 meters per second. So this is a bullet. Bullet has got, if you fire the bullet, okay, it is going to go out with a velocity of how much? 630 meters per second. Get it? Pretty fine, easy to understand. Acha, the rifle is fired at the center of a target which is 700 meters away. How much is the distance? It is 700 meters away at the same level as the target. At the same level as the target, okay. How far above the center of the target? How far above the center of the target? Now this is some mistake that has been made out here, okay. I'll tell you what is the question basically out here. Simple see understanding hai. What is it? There is a rifle out here, okay, and there is a bullet going, and here there was a target, okay. So at what distance above the target, should I actually place my rifle? At what distance above the target should I place my rifle so that it will go and hit the target right at the center? Okay, simple question. Okay, now see, try and understand what is it that we are trying to do here. If the bullet is going right this way, okay, definitely it is not going to go straight and hit it out here. The motion is going to be something like this, right? So we will have to target the center at a little higher height, okay. So let's say this is equal to the distance y, okay. Simple understanding of the entire question. How do we do it? We use, how do we do it? We use the equation of the trajectory. Now what is the equation of the trajectory? We have y is equal to x tan theta minus gx square divided by 2u square cos square theta. Alright. If you insert the value like x is how much? What is the distance? It is 700 meters, right? 700 meters. And we have theta. Now theta is going to be equal to what? Theta is 0 degree because it is projected horizontally, okay. So theta is equal to how much? 0 degree. Simple understanding. G is 10, x we know is 700, 2 u square, it is fired with 630 meters per second, cos of 0 is equal to 1. So you right away get the value of your y. This is a question which had appeared for 2011 JEE mains examination. Such a simple question, my dear students, alright. So mentally be prepared that yes, if there is a question coming, it's not going to be that it is going to be out of your reach, alright. You can definitely go ahead and attempt and get the question right. Generally देखा गया है that you have the question based on equation of trajectory. Equation of trajectory is one of the favorite areas of the examiner to give you a question, okay. So if you are revising your projectile motion, put it into your head that this equation should be definitely registered pretty well into your minds. Alright, now what we can do is we don't have to do anything, okay. Just simply put down the values and you'll get your answer. Now let me put it out here for you. Y will be equal to, see, tan of 0 degree will be 0 minus 10 x square 700, alright, divided by 2u square 630 into 630. That's it, cos square 0 degree is equal to 1. Simple idea, okay. Now 0 cancel, we will have this by 10 times, this will go 9 times, this will go 10 times, this will go 9 times. So the value of y will be minus, try and understand, this will go 5 times, so minus 500 by 81. Now see, in the JEE examinations, we don't want to spend unnecessary time doing the exact division. You divide this by 100. If you divide this by 100, what will be the value? 5. Okay, but you divide it by but the actual thing is it is being divided by a lesser number. So it will be slightly greater than 5. Okay. Now in the options, what do we have? Slightly greater than 5. Slightly greater than 5 is option C, that is 6.1. Right away mark 6.1 and you shall have your 4 marks in the examination. Okay, that's it. Fine. So now let's move on to the next question, students. In the next question, what do we have? Okay, now this is a interesting one. Okay. This is an interesting one. And what do we have here? So guys, would you like to attempt this question first of all? Would you like to attempt this question? Why not? Give it a try. Give it a try for at least for 2 minutes. 2 minutes. I will leave this question for you to think about it at least. Okay, before I go ahead with the solution. The position of a projectile launched from the origin at time t equals to 0 is given by r is equals to 40 I cap plus 50 j cap meters at time t equals to 2 seconds. Clear? That means the particle was launched from the origin, and as it is going, after 2 seconds, it reached a point whose position vector has been mentioned. It reached a point whose position vector has been given to me. What is that? 40 I cap plus 50 j cap, which is given out here. 40 I cap plus 50 j cap at time t equals to 2 seconds. Alright. Now, if the projectile was at time t equals to, if the projectile was launched at an angle of theta from the horizontal, then what will be the value of theta? That means if the projectile was launched from the origin at an angle of theta, we need to find out the value of theta from the data which has been given out here. Okay. Now, there is a long cut method to do this particular question, and also there is a shorter version of it. Okay. So guys, if anybody would like to give the answer, Pratham has already put down his answer as option C. Well, Pratham, your name as it says Pratham, that means first to give the answer, and yes, you are absolutely correct. The correct answer is option C. Yes, but how do we solve it so fast? Okay, have you done this question in advance? Arey Baba, Pratham, you that was a fluke by you, because just after that you mentioned it's option D. Okay, but if you are giving it a fluke also, then you would have got 4 marks. All right, but now let's look at this question, students, in a formal way, that how we should actually solve it, and then I'll tell you the shortcut method of doing it. Okay, so what we are going to do is, let me just rub off this portion. Yeah, one thing is for sure, projectile motion is definitely scoring in the JEE mains examination, and the questions are also not very difficult. Okay, so let me draw the axis, and we know this was what the projectile motion would be looking like. Okay, it was projected from the origin, at an angle of theta, So this angle here is equal to theta. Listen to it very carefully. Now, after time t equals to 2 seconds, where was the particle? Let's say the particle was somewhere out here. And this had a position vector. So this was the position vector of the particle out here, and this is given by 40 I cap. That means this distance which it has covered is 40, and this distance from here to here is equal to 50. Got it? So 40 and 50. Fine enough. So that is a position vector. Clear? If the projectile was launched at an angle, then find out the value of theta. We need to find out the value of theta. Okay. Now let's say this angle that this position vector is making. Listen to it very carefully. The position vector is making some angle, let's say that is alpha. What can I write tan alpha as? Tan alpha can be written as 5 divided by 4. So alpha can be written as tan inverse of 5 by 4. Right? It can be written as tan inverse of 5 by 4. Right? See, first I'll give you the traditional method. Okay, but well, I went into the shortcut method only in the very first attempt only. Chalo, I'll discuss about the traditional method after this. Let us learn the shortcut method. Okay. So you can see from this diagram itself, see theta, is it greater than alpha or is it less than alpha? Is it greater than alpha or is it less than alpha? Definitely you can see that it is, theta here is greater than alpha. So if my theta is greater than alpha, then definitely my tan of theta will be greater than my tan of alpha. Okay, will be greater than my tan of alpha. Where is the alpha gone? Alpha is somewhere here. Okay, let me move ahead. Okay, so what I can do is, students, let me rub this part and bring it to the next line. Okay, so we'll use some different color. So tan of theta will be greater than your tan of alpha, right? Tan of alpha is equal to how much? 5 by 4. It is equal to 5 by 4. So definitely from here, this data theta is greater than tan inverse of 5 by 4, right? This idea is pretty clear to all of you, isn't it? Now see, options dekho. So definitely this cannot be the right answer. This cannot be the right answer because that itself is equals to tan inverse of 5 by 4. All right. Acha, what about this option, 6 by 7? See, 6 by 7 is a value which is way lesser than 5 by 4. Okay, 6 by 7 is actually less than 1 and 5 by 4 is greater than 1. So this value of theta, of like the theta, is never possible because it is representing a smaller angle. So this option is also not possible. Okay. Acha, by the way, there could be now a 50-50 this thing between B and C, because B is 3 by 2, which is 1.5, and this is like 7 by 4. By the way, this option had actually 7 by 6. Okay, 7 by 6 happens to be like lesser than 5 by 4. So this also would not have been possible. But anyways, whatever we have been given out here, 3 by 2, we will consider that only. So here 3 by 2 is given and 7 by 4 is there. So we will need to follow the traditional, or let's say a little longer method, whatever is there. But yes, if one of the options is given to be having a value which is lesser than 5 by 4, then we can cancel this also, and finally we are left out with option C. Fine enough, students. I hope everybody understood it. I hope everybody also appreciated it. So guys, go ahead and click on the like button if you have enjoyed this particular solution. Okay, chalo guys, now let's look at a little longer methodology. Okay, in the longer version, what are we going to do? Let me just talk to you about that. So anyways, let me just rub it off here. And I'll just put down the fact that theta is going to be greater than tan inverse of 5 by 4. Okay, so let me go ahead and discuss. Do we have some space out here? So otherwise I'll have to rub off this particular part as well. That's what I was actually thinking. So anyways, what we will do is, let me just clear off everything right now. Okay, and we'll discuss the entire thing once again. Okay, that is a longer version of it. Now in the longer version, what we shall have is, this is the position vector of the particle, that is your 40 and 50. We can find out definitely what is going to be your ux and uy. Ux, this is the velocity, the horizontal component of the velocity, and they have given us the position vector after 2 seconds, right? So after 2 seconds, it must have traveled 2 into ux, and that is equal to 40, because along the x-axis it is what? It is a uniform motion. There is no acceleration at all, isn't it? There is no acceleration at all. So ux value will be equal to how much? Ux value will be equal to 40 divided by 2, that will be equal to 20 meters per second. Clear enough? Although the long cut method is also like really short. Okay, by the way, let's move ahead. And here the vertical displacement is 50. Vertical displacement, can I write down my Sy is equal to Uy into t minus half gt square. Now what is Sy? We know it is equal to 50. Uy I don't know. Time t is 2 seconds, minus 10 divided by 2 is 5 into 2 square, that is 4. So I can write down 2 times uy will be equals to 50. This will come to this side, so it will be plus 20, which implies your uy will be equals to 70 divided by 2, that will be equal to 35 meters per second. Clear enough? As simple and straight as that. Now, how do I find out the value of theta? Value of theta, kindly see, that value of theta out here, if you see, then tan of theta will be equals to uy divided by ux. So, you will get the value equals to 35 divided by 20, 5 7 times, 5 4 times. So, theta will be tan inverse of 7 by 4. Clear enough? I hope everybody has understood the method of how to go ahead and solve this particular question. Okay guys, now let's do one thing, let's move on to the next question. Alright, now in the next question what do we have is, what do we have in the next question? Let's see this. There is a ball which is projected from the ground, at an angle of 45 degrees. Now, when they say you 45 degrees, students understand what is the first thing that comes to your mind? What is the first thing that comes to your mind? Maximum range, okay? And do you know that maximum range is equals to 4 times the maximum height? I hope all of you are aware of this particular thing, that maximum range is equal to 4 times the maximum height. Yes. So, that knowledge should be very clear, then you can do this question really fast. Okay. Now, just clears a wall in front. If the point of projection is 4 meters from the foot of the wall. Okay. So, let me just draw the situation out here. Let me draw the wall out here. Now, if the point of projection is 4 meters from the foot of the wall, so this is my wall and the point of projection is here, which is at a distance of how much? 4 meter from the wall. Fine enough, okay. And the ball strikes the ground at a distance of 6 meters on the other side of the wall. So, from here to here, the distance is how much? 6 meters. So, what is the total range? What is the total range? The total range would be equal to 10 meters. Clear enough? So, let me just draw the projectile. So, it must have dropped here. And the highest point would have come at what distance? This distance would be equal to 5 meters, isn't it? This distance would be equal to how much? 5 meters. Now see, I'll do this question in like 2 steps. Alright. Such a big question where we had to solve so many different equations, but we will skip all of that and do this question in like 2 steps. How exactly? Excited? Fine. Let's listen to this. Now we know this relation. This relation is very important. R is equal to 4h. This is for maximum range. So, h can be written as R divided by 4. Okay. You need to know this information. If you know this, only then you can solve it in like 2 steps. Okay. Now, here what is the range? 10. 10 divided by 4, it will become equal to how much? 2.5 meters. So, this height will be equal to 2.5 meters. And what is this? This is the h max. This is the maximum height, students. If this is the maximum height, then height of the wall cannot be definitely greater than the maximum height in the projectile, right? That means the option of 3.6, 4.4 gone out of the picture. Fine enough. Now we have 2 options left, right? We have what? 2 options left. What are they? We have got 2.4 and 1.6. Now, let's do it by the method that we learned in the last question. What was that? See, you draw from the point of projection to the height of the or the end of the wall, and from here to the highest point. Okay. From here to the highest point, listen to this very, very carefully. This solution you will not get anywhere else. Okay. This is the second step of the entire solution. See, the top of the wall here and the highest point here. What is this angle? Call it as my theta 1. What is this angle? Call it as my theta 2. From the diagram, can you tell me what is the relation between theta 1 and theta 2? Theta 2 is definitely greater than theta 1. Theta 2 is definitely greater than theta 1, right? That means tan of theta 2 will also be greater than tan of theta 1, correct? Tan of theta 2 will be greater than tan of theta 1. Acha, tan of theta 1 will be how much? 2.5 divided by, what is this distance? 5. So I can write this, I'll put it here. Tan of theta 2 will be greater than 2.5 divided by 5, that is equal to 1 by 2. That means it will be greater than 1 by 2. By the way, what is tan theta 2? Tan theta 2, if you look at it, it is the height of the wall, which is, let's say, is equal to y, alright, divided by how much? It is at a distance of 4 units. So I can write here y divided by 4 should be greater than 1 divided by 2. So 2 and 2, this will become your y greater than 2. Are you with me? What do you see? The height of the wall should be greater than 2 and it should be less than 2.5, right? That means there is only one option which satisfies this particular relation, that is the height of the wall is greater than 2 and it is less than 2.5, so it is only 2.4. Option D is also gone. So guys, if you have enjoyed this particular solution, there is someone, Shubh Lata, you have a little bit of a doubt. Okay, tell me, what is your doubt? If I can go ahead and help you with your doubt. Okay, once again, I am telling you the last step. Once again, students, listen to this very carefully. Okay, see, solved it in 2 steps. Such a lengthy question. This, if you go by the normal method, this question has got at least 5 to 6 steps. Alright, and once you keep doing it, it will take you more than 10 minutes to get to the final solution. Okay, what did we do? Let me get to you. We found out the maximum height. See, this relation was important. If you know this relation, R is equals to 4 times H for 45 degree condition. Okay? It is only true for 45 degree. Remember that. This is not true for all cases. So don't go ahead and put this for all the cases. Okay? It is only for 45 degree this relation is true. So from the range, I was able to calculate the height max. Now I know the height of the wall, which is located at 4 meter, will be lesser than the height of the maximum height, or maximum height of in the projectile achieved, that is 2.5 meter. So height of the wall will be less than 2.5. Okay, we got that height of the wall is less than 2.5. Pretty fine. First part of the question is done. From there, what I did, I cancelled out option A, I cancelled out option C, because these are values which are greater than 2.5. So totally gone. Now comes the second part of the solution. What I did, I connected the point of projection to these points, alright. Now what did I see out there? I calculated these angles and saw that my theta 2 is greater than theta 1, which implies tan of theta 2 will be greater than tan of theta 1, right? What is tan theta 2? Tan theta 2 will be equals to height of the wall divided by 4 units, and tan theta 1 is 2.5 divided by 5, which tells me y divided by 4 will be greater than 2.5 divided by 5 is half. So this is 1 divided by 2. So y will be greater than equal to how much? 2. So we got the value of y to be greater than 2 and less than 2.5. So which is the option that matches? It is only option B. I hope, Shubhalata, you got the answer right now. Thank you very much. Chalo guys, let's move on to the next question. Okay. Chalo, if you enjoyed this particular question, guys, go ahead and press on the like button. Okay. Do not forget to press on the like button if you have enjoyed this particular question out here. All right. Let's move ahead now. Now, this is one question which has come in previously. All the questions are from JEE Mains, by the way. Okay. This is on circular motion, you would say, or you can also say it is on your relative velocity concept. Okay. Well, not exactly relative velocity. Yes, relative velocity, relative speed, we can talk about it. Let's go through the question. I'll give you 2 minutes to read and think about the question, and then we can go ahead and talk about it. Okay, and it's a very simple question. It's not a very tough question, so you can expect, just looking at the question and the length of the question, do not get frightened. That's what the entire point is. Okay, two identical discs. So I have disk 1 and I have got disk number 2. Fine enough, I have got disk 1 and disk number 2, and they have the same radius. What do they have? They have the same radius and are rotating about their axis in opposite direction. So I have got two discs, disk number 1, disk number 2. Disk number 1 is rotating like this, disk number 2 is rotating in this particular way. Okay, so they are going like this. All right, now the discs are in same horizontal plane. By the way, they are rotating with angular speed omega. They are in the same horizontal plane at time t equals to 0. The points P and Q are facing each other as shown. So this is point P and this is point Q. As shown in the figure, the relative speed between the 2 points is given as your VR. In one time period of rotation of the discs, VR as a function of time is best represented by which graph? Okay, so VR as a function of time is best represented by which particular graph? Okay, what is VR? VR is the relative speed. It is what? It is the relative speed of point P with respect to Q. So I hope everybody's got the question. Okay, I hope everybody has got the question. No, it's not a difficult question, Shivlata. It's rather a very, very simple question. Okay, let's get to it. Let's get to the bottom of it. Try and understand that this will have a velocity in the downward direction and this will also have the velocity in the downward direction, right? Both the points P and Q, they will have their velocities in the downward direction. So what will be the relative velocity at this particular point at time t equals to 0? At time t equals to 0, your VR will also be equal to 0, right? Now, if VR is equals to 0 at time t equals to 0, then option B and option D goes totally out of the picture, right? It's a 50-50 scenario right now, okay? A higher chance for your getting this question right, isn't it? So, we have option A and option C. We have option A and option C. Now, the question is, how many times do we get a maxima in one time period? 4 times do we get a maximum or 2 times do we get a maximum? Okay, or how many times the relative velocity becomes 0 in one time period? In one time period means P has rotated completely and come back here and Q has rotated completely and come back here. Okay, so what are the different points? I can say this is time t equals to 0, this is t by 4, this is t by 2, and here this is 3t by 4 and again t. This is t by 4, this is t by 2, this is 3t by 4 and this is again t. Okay, so let us try and understand what is happening at time t equals to 0, VR is equals to 0. Okay, now look at this particular point here. They are in the same direction only 2 times. They are in the same direction, see, Vp, Vq, Vp, Vq, they are in the same direction twice. That means their relative velocity will become only 0 2 times in one time period. That means the relative velocity will become 0 twice, only twice, okay, whenever their velocities are same. And in velocities you need to consider the direction also. So here velocities downward, velocities upward. Here when they are facing, their velocities are not in the same direction. So at these 2 points, that is this point and this point, they are going to have a maximum value. Here the relative velocity, this particular point, the relative velocity will become equal to what? 0. And here also 0. That means, which option is the correct one? Option A will be the correct one. Even without dropping your pen, you can actually solve this particular question. Okay, you just need to think a little bit. Just the length of the question does not actually matter. You just need to be a little careful in reading the question, understand what is the question is being, what is being asked in the question. Once you get to that particular point, bang on, you can get through any particular question. You just need to understand, okay. See, smart, you need to be very, very smart to deal with the JEE mains questions. That is the bottom line, students, okay. Now, let's move ahead to this particular question here. Now, this question has got a little long discussion, okay. It's a little concept based, let me tell you, okay. And yes, before we go ahead and do this question, why not finish up with this question, which I think something to give you a little bit of chill and fear. All right, yeah, projectile motion, and we have brought in inclined plane. That means it is going to be not just one inclined plane. I have brought in front of you two inclined planes. So definitely a little bit of a fear is there, right? Chalo guys, I hope anybody knows what will be the answer. What will be the answer of this particular one? The velocity of the striking. These are the options for the velocity. So can somebody tell me? See what is happening out here. This is one inclined plane. Try and understand the question out here, students. This is one inclined plane, and from this inclined plane, there is a projectile which is going in this particular direction, perpendicular to the plane, okay. It goes and strikes to the other plane in a perpendicular direction. Then if this was projected with a velocity u, which is given as 10 root 3 meters per second, then what shall be the velocity when it strikes this particular plane? All right. Chalo guys, let's see if anybody gives me the right answer out here. Well, option B, someone saying option B. Well, Vikas and Asha is saying me option A. Good guys, good, you guys are trying it out, okay. So let me just see how to do this question. Like really fast without using any projectile motion equation at all. Little bit of a common sense and smartness will get you through this question, okay. How do we do it? Try and understand. See this u, if I draw a horizontal out here, try and understand. See this is 30 degree, isn't it students? So this will also be how much? 30 degree, right? 30. So how much will be this angle? This angle will be 60 degrees, okay. So what will be the component of velocity in this direction? U cos 60 degrees. Can I write it as u into 1 divided by 2? So this is the horizontal component of velocity, that I can write it as ux, okay. Now whatever is the horizontal component of velocity, is it going to change? The velocity in the horizontal direction, does it change? Is there any force in the horizontal direction? No, there is no force in the horizontal direction. So there is going to be no change in the velocity in the horizontal direction. Now here, if you look at this v, the horizontal component of v is going to be how much? If you look at this is 60, so this will be 60, this will be 30 degrees. See, try and understand, this is 60, this will be what? Corresponding angles. That's why 60, but this will be how much? 30 degree. So this is v, so this will be v cos 30. Now if the horizontal component, remember this particular point, if the horizontal component of the velocity does not change, then students, can I say that my ux which is equal to u divided by 2 will be equals to v cos 30 degrees, which can be written as root 3v divided by 2. 2 and 2 will cancel, which implies the velocity of landing will be equal to u divided by root 3. And what was u? 10 root 3. 10 root 3 divided by root 3, root 3 cancel, equals to 10 meters per second. So option C is the right answer. Option C, students, is the right answer out here. Alright. So I hope you enjoyed, because none of the equations of your projectile motion in your inclined plane was used here, and we did it simply by using a simple logic. We all know this logic, right? That is, the horizontal component of velocity does not change because there is no force in the horizontal direction, right? Because there is no force in the horizontal direction. Simply using this particular concept, we got our answer correct, right? Chalo guys, now let's move ahead to the next question. If you have liked this particular one, do not forget to press on the like button. Okay guys. All right. Chalo, now next question se pehle we go to the previous question. Okay. See, this is a simple understanding. Whenever it comes to projectile motion, the examiner's favorite is to involve collisions. All right. There will be two projectiles, say one projectile, definitely they come for advanced level, but yes, sometimes even in the JEE mains level also they have asked you questions which are having projectiles and there is collisions happening between the two projectiles. So what is happening here? Now there are even more difficult problems, okay, where one is like going horizontal projectile, another one is going like this oblique projectile, and then they meet out here, and where are they supposed to particularly fall, find out the distance from one of the point of projection, and all those questions are there. But again, like those are superly advanced level problems, but we are not going to look into those things. But definitely this question requires a little bit of an attention. Chalo, subjective question, it's not an objective question. So here let's try to get the maximum out of it. Let me explain to you. I don't need to read through all of this. There is a 20-gram particle and here I have got a 40-gram particle. All right. This is a 20-gram particle. And they have been projected. One is projected at 45 degree, other one is projected at 135 degree. So basically this angle is also 45 degrees. Simple idea. Okay. Now, they collide at the highest point. They are colliding at the highest point. Okay. And after this collision, this particle is retracing, like let's say this is here and this is here. This retraces back its path. That means it comes from here to this point here. Then where exactly will this particle go? Where exactly will this particle be go after the collision? This is what the question is. All right. I have two particles, both particles travel in the same vertical plane and undergo a collision. After the collision, P, that is this particle here, retraces its path. Determine the position of Q when it hits the ground, and how much time after the collision does the particle Q take to reach the ground. All right, simple question. How do we do these kind of questions? See, understand students, whenever there is a collision based problem, understand that we need to apply the conservation of momentum principle. If we are able to apply the conservation of momentum principle, then my question is through. Try to see, advanced level question can be done in like 3 steps. All right, 2 to 3 steps maximum. Let's say this has a mass m, so this mass be 2m. So P has a mass m and the other mass is 2m. Clear? So this is going to hit m and here another particle is coming 2m. Try to understand this. Okay. This is going to come with what velocity? This is going to come up with what velocity? See, the initial velocity is 49 meters per second for both the particles, for this particle also and this particle also. At the highest point, they will be actually coming up with the same velocity. All right, they will be coming up with the same velocity, right? So here this is coming up with u and this is also coming up with u. Let me say that horizontal component of the velocity is u at the highest point. Fine enough. Then what is the initial momentum? mu minus 2mu. What will be the final momentum after the collision? Just after the collision, it is going to move in this direction with the same velocity if it has to retrace back its path out here. So final momentum will be minus mu plus 2m. I don't know what will be the velocity, let's say v1 after the collision, right? So now here simple idea is you bring it to this particular side. So here this will become 2mu minus 2mu is equals to 2m into V1. So what we see is V1 is equal to 0. So basically this is going to drop right out here. All right. So that is the solution, and you can easily find out what is the range. So just at the highest point, the other particle is going to drop down out there. Okay. Now students, that's it like for our today's session. Now let me go ahead and let me talk to you about the very special features of the Unacademy channel. That is, we have the Instagram page. Do go ahead and check out the latest updates which are there, and the Telegram app. Definitely it is kind of very important because of the very fact that you get to chat with us on a regular basis. So download the Telegram app and send all your doubts, whatever queries you have in your mind, so that we get to interact with each other on a daily basis. All right. And students, for your Unacademy subscription, remember, for more such by the way, students, let me tell you one thing. Nikunj is saying, sir, I'm planning to get plus in my 12th grade, but my school timings are in the evening. So will I be able to contact the educator after the live class ends as 50%? I will be able to join. Okay. So see, Nikunj, its sessions are being held throughout the day. Okay. It's not that sessions at Unacademy Plus are only happening in the evening hours. All right. So there are some sessions which are happening even in the morning, in the afternoon, and there are like lots and lots of teachers who keep taking lectures, like, you know, at all points in time. Okay. So definitely you can interact not only, like, you know, after. Okay, we have the Telegram channel, a Telegram app and all that, so you can directly interact with them there, but also during the sessions in the morning, you can attend the plus channels, like, you know, the Academy Plus platform, and ask your doubts and queries and interact with the educators live out there. Okay, so you should not worry about it at all. Okay, Varun, we will talk about it later. Fine. So guys, about Unacademy subscription, if you have not got it so far, you can see a beautiful Namo sir out here. You can attend all the live classes out there, chat with the educator, and definitely, like, you know, there are very interesting polls. So the classes are kind of very interactive between the educators and the students. It's not a monotonous thing where the teacher goes and on talking. There are like beautiful interaction that keeps taking place, and we have the test series and the analysis of like, you know, not just your regular classes keep happening, but we have lots of test series and their analysis, so that you can learn maximum out of these sessions. And we have live doubt clearing sessions. Students, live doubt clearing sessions, what do we understand by that? See, simple idea. If you are having any particular doubt in any questions, okay, not just related to this particular topic, but from anywhere, you can just take a photograph and upload it as a pic, and then the doubt comes to the educator, and then based on how the class is progressing, the educator would give you the solution to the doubt right then and there itself, or towards the end of the lecture. Okay, so you have live doubt clearing session. Students, this is a very important feature. Okay, now next, coming ahead, we definitely have the best educators of the country on this particular platform. Okay, we have the best educators on this particular platform, so don't miss out on the chance of actually being a part of this huge family that we have like, you know, gathered together as under the platform of Unacademy. Okay, and students, definitely, if you haven't gone ahead and subscribed as yet, then for the plus subscription, all you need to do is search for an Unacademy learning app. Once you get it, install it. Just press on the install button. Okay, once you do it, students, go for the plus subscription. go for the plus subscription. Choose IIT JEE, that is the course that you're enrolling for. Click on the get subscription button, okay? And once you do it, use SMLIVE as the code and press on the apply button. Use SMLIVE and press on the apply button. Right away you will get a 10% discount, okay? So instead of 35,000, you will be paying only 27,000, and that too for such a huge base of educators. All right, and students, yes, definitely we have this as the JEE English channel, and our daily sessions are going to be here. Daily lectures are going to be conducted in English in this particular channel. We have the presently the sprint thing running on. So if you haven't subscribed as yet, do press on the subscribe button and do not forget to press on the bell icon, so anytime we have something new coming up, you should be informed about it. All right, students, and then finally, in the JEE English channel, or let's say the NEET, the JEE, the foundation, we are here to crack all of these examinations, okay? And definitely, before I leave the session, SMLIVE and get 10% off on your subscription. Thank you and God bless you.